chemical bonds are distinguished. There are two types of chemical bonds. We have ionic bonds and covalent bonds. In ionic bonds, the electron is being given away by a metal and being taken by a non-metal, and then the resulting ions are attracted to each other because they're of opposite charge. In a covalent bond, the valence shell of two atoms are sharing two or more electrons. So the electrons in an atom occupy different levels or orbitals. We've learned this from yesterday. And the filling order in atoms is 2, 8, 8, 2, in atoms as big as up to the size of calcium. In atoms that are bigger than calcium, the shells fill 2, 8, 18, 2. And you'll see next year when we investigate this a little more in depth that there's a whole theory behind how electrons pile in around the atoms. But for the purposes of grade 10, it's enough to know this, that it goes in shells and that they go 2, 8, 8, 2. The last, or outer shell, is called the valence shell of the electrons. Everything we call chemistry takes place on the outer shell of electrons. Everything, every chemical reaction that takes place because of that last shell of electrons on the outside layer. So valence electrons are the only electrons that participate in bonding and chemical reactions. And atoms with filled shells are particularly stable, and because of that, they're quite unreactive. The atoms that we find which are not very reactive are called noble gases, and they represent group 18 of the periodic table: helium, neon, argon, krypton, xenon, radon. These are the noble gases, and they all have filled valence shells. All the other atoms that don't have filled shells will try to adopt the electronic structure of the closest noble gas. So for example, when fluorine becomes an ion, when it becomes fluoride, it gains an electron to become similar in electronic structure to neon. When oxygen becomes oxide, it gains 2 electrons to become similar in electronic structure to neon. And there's a special word we have for when atoms have the same number of electrons. It's called isoelectronic. Nitride anion, which is -3, will gain 3 electrons to become just like to become isoelectronic with neon. So how do ions form? Or how do we represent the formation of ions? If we look at atoms like the alkaline metals and the alkaline earth metals, which occur in group 1 and group 2 of the periodic table, I took an example with lithium. Lithium is an alkaline metal. If you heat lithium so that it becomes a gas, you get it to the point where it's a gas, and then you heat it even more so that you start pulling electrons from the atom, you'll get lithium ions. So when the lithium loses an electron, the outer electron, the last one in the last shell, the valence shell, it becomes isoelectronic with helium, which is the closest noble gas. So here I've shown the structure of lithium, which has 3 protons, and when it loses that outer electron, it starts to resembles the electronic structure of helium, and you'll notice it has a positive charge. Magnesium, when you heat it up to form magnesium gas, and then you heat it up yet again to a higher temperature, it'll ionize to form magnesium cations. It'll lose 2 electrons, and it'll become isoelectronic with neon. And I've represented that over here. You see the magnesium cation, it's got a +2 charge, and it's got 10 electrons. It's got 12 protons, but 10 electrons. So what is an ion? An ion is a charged particle. It's an atom that has either more or less electrons than it would normally have in the ground state. Cations are positive particles, and ions are negative. A good way to remember that is to use the little mnemonic, cats have paws. So cations are positive. Metals tend to form cations. They tend to become positive. They tend to lose electrons. Non-metals tend to gain electrons. So the valence, a few words that we have to define. Valence electrons are the electrons in the outer shell of an atom. The octet rule is that atoms tend to be stable when a shell is complete. And metals tend to lose electrons to achieve a stable octet, and non-metals gain electrons to achieve a stable octet, again trying to become like these noble gases. And isoelectronic means having the same number of electrons as another element. Stable ions tend to be isoelectronic with the closest noble gas. They lose or gain electrons from their valence shell to achieve a stable configuration. Let's look at an example of how an ionic bond forms with precisely this idea. Whenever you have a metal joining to a non-metal, the metal will lose electrons whereas the non-metal will gain them, and then the resulting ions will be attracted to each other by electrostatic attraction. When two non-metals react, what you'll get is a sharing of electrons to form a covalent compound. So if you take, for example, sodium in the ground state, sodium has 11 protons and 11 electrons when it's neutral. Chlorine has 17 protons and also 17 electrons. Now what happens is sodium will tend to lose that last electron, the valence shell, and then it'll have 10 electrons. It'll still have the 11 protons because it's not called sodium unless it has 11 protons. Having lost that last electron, it now has a positive charge. Chlorine, on the other hand, will gain one electron to become chloride anion, and now it'll have a configuration which resembles the configuration of the closest noble gas, which happens to be argon. It'll be 288, just like argon. So chloride is isoelectronic with argon, and sodium cation is isoelectronic with neon. Now that you have an Na plus and a Cl minus, the two particles are attracted to each other and they form sodium chloride, which is a matrix of Na and Cl minuses next to each other, alternating, so that no particles that are positive are close to each other and no particles that are negative are close to each other. In a covalent compound, for example, like naturally occurring chlorine, there's a sharing of an electron pair to form a covalent bond. Here I've drawn the full orbitals as circular representations, which is fine for grade 10. In grade 11 you'll see that they actually have different shapes. Here's chlorine with its 17 electrons, 2, 8, and 7. There's 7 in the last shell. So if it were to have one more, it would have a filled outer shell. Same with the other chlorine atom. So what do? They end up sharing the outer electron, the one electron pair, and that results in a bond, because a shared electron pair is like two people holding on to the same thing. You have a bond with the other person if you're both holding on to the same thing. So a covalent bond occurs when two atoms share an electron pair. It forms a link between them. This linker connection is called a covalent bond. In an ionic bond, when one atom gives up an electron to form a positive, or cation, to form a positive particle, I should have written, and another atom gains an electron to form a negative ion, an anion, the two atoms will attract each other by electrostatic attraction. So one good rule of thumb you can remember to help you judge whether something is going to have an ionic bond or a covalent bond is that the farther apart two atoms are on the periodic table, the more ionic is the character of their bond. So for example, if you have potassium combining with chlorine, that is a good indication. They're far apart on the periodic table. That's a good indication that you have an ionic compound forming. If on the other hand, you have fluorine bonding with fluorine, you're going to have a covalent bond because fluorine obviously is very close to itself. Or if you have sulfur combining with chlorine, they're very close together on the periodic table, you're going to get an ion, and you're going to get a covalent bond. Another example, if you have cesium combining with iodide, cesium iodide is an ionic compound. So far apart tends to form ionic bonds, close together tends to form covalent bonds.